Hi guys, welcome back. So in my previous lesson we had discussed about plane mirrors, and in case you guys missed it, please do check it. It's given in the description below. In today's class we will discuss about curved mirrors, right? Curved mirrors are basically made from a glass sphere, right? So you take a glass sphere and you take a part of the glass sphere and coat it with silver. You have a curved mirror. There are of two types, concave mirror and convex mirror. So let's discuss about them today. So here we have the glass sphere, and from the glass sphere we are only taking a portion of this, right? And we are coating this with the mirror material, which is silver or aluminum. So the minute you coat this particular portion of this is what becomes a curved mirror. Okay, so curved mirror is of two types. The first is called the concave mirror, and the second one is called the convex mirror. Okay, we can discuss about certain ray diagrams which is helpful for doing the image formation in both these type of mirrors. Here we have a sphere, and we have the concave mirror which is shaded, and if you look at the center of the sphere, that is what is called the center of curvature. It is designated by C. Okay, and if you look at that P is nothing but the pole of the mirror, is the geometrical center of the mirror. Okay, so if you join C and P, that is going to be equal to the radius of the sphere. Therefore, it is CP is going to be equal to R. In between CP, we have a point called the focus, and focus is exactly in between this. Therefore, between the pole and the focus is called the focal length. That is going to be R by 2. Okay, so we have the center of curvature, we have the pole, we have the radius of the sphere, we have the focus, and we have the focal length. And with this definition in place, we can go ahead with the ray tracing rules. So let's forget the outside shell, and this CP is also called the optical axis. And let's take an object on the optical axis. Okay, how do we form the image here? We are going to follow two rules. Okay, the first rule is, if you are having a ray of light that is coming parallel to the optical axis, okay, then after hitting the mirror, this ray is going to get reflected and will pass through the focus. Okay, so the first rule is this: ray parallel to the optical axis will always go through the focus. Rule number 1. Then we employ a second rule for doing the image formation. What is that second rule? Any ray that goes through the center of curvature is always going to retrace its path. That is going to be rule number 2. You will ask why? Why does the ray retrace its path? Because if you see, a ray that passes through the center of curvature will always be normal at the point it is going to hit the mirror. So if it is the ray is incident normally, it is also always going to retrace its path. So we have now two rays, and both these rays are intersecting at a point. Once we have the point of intersection, we can draw the object. Okay, so using these two rules, you can find the image formation in the case of a spherical mirror. I hope you have understood this. So now that we have seen how the image is formed, we also need to give the characteristics of the image. Okay, so when we say characteristics of the image, the first thing here we notice is that the image is formed because of the intersection of the real rays. Okay, so because both the rays that were reflecting are meeting, the real rays are meeting, therefore the image formed is called the real image. All real images are going to be inverted in nature. Okay, so our image was a real image and it was inverted. And if you see the size of the image was diminished. Okay, so the characteristics of the image formation of the case that we discussed was, it was a real image and it was a diminished image. Thank you so much for watching our videos. Please like and subscribe to our channel. Be sure to share it with your family and friends, and don't forget to visit our website www.cogitarelearning.com, where you have linked to all the videos that we have been recording so far. Thank you once again.